Turned out to be a person comments. Oh my god. So he has a little bit, his head is a little bit too big, but that's okay. Just for no reason.
We're good.
Awesome.
No one cares about it. Just
Good morning. How's everybody doing today?
wonderful. How are you?
I'm, doing okay for a Monday.
Cool.
Nobody's sick at the moment, so I'm good. Yeah. So, we have a little bit to finish off with respect to Git, and then we need to move swiftly onward because the course creeps forward. Time forward slips, death soonest nips. So, let's do it. So, I hope you all remember all of the stuff from yesterday or last week, because it's going to be very important when you guys want to try to submit your assignments. Incidentally, GitLab.com is not the website. There's a special CAS version, so use the links provided, please. If you just Google GitLab and then pick the link, you'll find something that's not what you're looking for. So, it's got to be the departmental GitLab server, please. So, at any rate. So, to quickly recap, the command sequence for, the general internet commands for Git, which allow you to interact with remote servers, are clone, which creates a local instance of a remote repository, push, which transmits your commits to the other networked computers, and git pull, which receives commits from the other network repos and checks out the current head. Make sense? Good? Hopefully. I have a clicker now. Let me use my clicker. I got a real laser sword too. So, if your repo is being hosted by GitLab or GitHub, they have a handy button you can use to get the correct URL. So, this is from GitLab. If you hit clone, you can clone with either SSH or HTTPS. Given that last time I logged in class, they were asking for like advanced SSH certificates or some kind of configuration, probably HTTPS will be your most efficient way of getting in, so that'll be fine. So, collaborative workflow. When you're working on a Git project with other people, in general, there are some rules of etiquette. Number one, always pull changes before you start working on something. Number two, always push your changes promptly when you're finished. Don't wait till after lunch, right? Push your changes before you go on lunch, right? Document your changes, period, exclamation mark. How is anybody to know what you've done, what you've changed, if you haven't said that to anyone? You've just made a bunch of random modifications to files. Any major changes, such as new features, should be made in a separate branch, and then merged back into master when the new feature is mostly complete. So, you pick off a branch, you make your modifications in that branch, and then you merge that back in. That way, you can do whatever you want with the code, you can modify it in whatever manner you see fit, but the master branch isn't modified or affected by your changes while you're working on it, right? Once you merge everything back together, then everybody can see your hopefully complete feature, right? Make sense? It is your job to keep master stable at all times. This is the expectation, is that the master or main branch will be stable no matter what. Adding a feature or even general development will often break things for a while, as I'm sure all of you know, and pushing broken code into master is the height of bad manners. Once your branch is finished, you can merge it back into master often with minimal effort. One of the nice things about Git is that it has rather intelligent systems for managing merger of file versions into each other. That's one of the reasons that Git is, preferred in a lot of cases. This way, people's changes remain isolated throughout development. So, if the green here is the master branch, if you pick off a branch of your own, after this commit, work on it, right? Master is still being updated. Someone else can pick off a branch. You can merge back into master. They can merge back into master. At the end, both of your features or modifications that you've made will be in here, but you don't have to worry about, what they're doing, and they don't have to worry about what you're doing until the end. Make sense? This is a lot more efficient than emailing files around. Question?
Let's say you both change the same thing and then merge them together. How does it know which one is it?
That's an excellent question. You have asked me what you do in case of a merge conflict. Well, let's talk about branching first, because I've actually got some slides on it. So, branching is easy. To create a new branch, you use the command git branch and you select the branch name. The branch name should be informative. This creates a new branch with a given name. You have to switch to the new branch manually if you want to use it. So it creates the branch, but it doesn't put you in the new branch. You'll still be in the source branch. And whatever branch you're in at the time that you make the branch, that's the branch you're branching from, if that makes sense. Like, for example, these things really are unreasonably heavy. They have no business being that heavy unless they're made of real slate. So let's say you have some kind of master main branch, right? You pick off a branch over here, make some modifications. Someone's like, oh, I like what he's doing over here, decides to branch off that branch. So you can have another branch come off of your branch, right? Hopefully then, you merge back like that. Make sense? This isn't especially common, but it does happen. Make sense? Especially, the more complicated the project is, the more of these you're likely to see. So, git switch allows you to switch to the branch with a specified name. Very basic. Similar effect to changing your working directory in a file system. So whenever it's also very similar to the git checkout operation, which allows you to get into previous commits, right? It's like you can basically, what happens, from a physical standpoint, all of the files in your file system are modified to reflect the commit that you're changing to, right? When you're switching commits, you're just switching normally to the head of an unclosed branch, right? So all of your files will be modified to that state, and if you committed before you did that, you can always bounce back into the branch you were in before. Make sense? Navigation. Good. Any questions? Good. Git log all displays commits from all branches, not just the active branch. So that's what a git log all graph if you add the graph option as well, you get something that looks a little bit like that diagram over there, but done in ASCII. So let's, I just want to, let me show you something quickly from another class I teach. They've got like a, they've got like a lab activity where they have to merge a whole bunch of branches, and that's the activity. So git log one line graph all. So you can see these things can be fairly complicated, right? They don't like this lab, generally. But I make them do it anyway because it's good for the soul. Suffering is the only true path to enlightenment. So, so let's talk about forks, right? Forks are different from branches. Branches remain in the same repository. What a fork is when you see someone's project and you're like, man, I really like this code, but I have a different vision. I want to take this in a whole new direction. And also, I don't like the people who are working on it, typically. So, you can essentially clone someone's project in a manner that disconnects it from the existing Git repo. You then have your own copy. Your modifications do not get seen by the other project, right? So, yeah. A fork is a branch operation over an entire repository. Forking is often used to start a new project from an existing one. So, for example, one of the most famous forks is OpenOffice and LibreOffice. So LibreOffice was forked from OpenOffice in 2010 because some of the OpenOffice community members didn't like how Oracle did its licensing from previous open source projects. So OpenOffice was done by Oracle, but had strange licensing. So they made a fork of it called LibreOffice. Libre, of course, being French for free. So over time, LibreOffice 100% won the fight between the two. Like if you download OpenOffice, it is like people accuse a LibreOffice of looking a bit like Word 95-ish, you know? But like friggin' OpenOffice is like Windows 3.1, man. It's like I'm not sure it's even actively under development anymore. But there are other open source Office projects, of course, but you know. Yes?
How does forking affect legal ownership and stuff like that?
Well, it depends on how it's been licensed, right? If it's been licensed under the GNU General Public License, then normally the only thing that's required is attribution, you know, and perhaps continuation of a non-commercial status. But within those parameters, you're pretty much free to you know, take the project wherever you want, right? But yeah, look up copyleft licensing, and you'll see, and Creative Commons licensing, and you'll see what the licensing terms are for a number of these types of projects. One of the things that I think GitHub will prompt you to do is select one of these styles of copyleft licensing. Any other questions? Okay. There's no command for forking with Git, but many Git GUI tools have a button for it, including GitLab. So One of the sort of metrics of popularity which GitHub, maintains is how many times your project has been forked by other people. So, yeah, to even have one is usually pretty impressive. So let's talk about merging. Git Merge branch name merges the specified branch into the currently active branch. So it's a get over here operation, right? It's not like you have to be sitting where you want the branch to be merged into, and you have to specify it, grab it, and yank it in, right? Merging requires a commit message, and Git will prompt you with one for a text editor if it's missing, just like everything else. You can see which branch you're in by using git branch. You can also just use git status to see where you are. Git is pretty clever at merging branches, but there is always a possibility of merge conflicts, which are the worst thing in the world. But better than any other mechanism that humanity has discovered for managing them so far. So, if the changes are in different files, then everything's fine. You just do the changes in the two files and everybody's happy. If the changes are in different parts of the same file, merger is trickier, but it will probably still work without requiring any human intervention. Normally, the only time you run into a Git merge conflict is when the same parts of the same file have been modified differently in two different areas, right? So Git is using line number primarily to determine where conflicts are and aren't. Like, it can tell when lines have been added, of course, but if you normalize for lines being added and deleted, it's using line numbers to compare lines between two different file versions. So if you have modifications on the same line in two different versions, then you have a problem, right? Make sense? And effectively the only way to get around a merge conflict once it occurs is to go into the file yourself and modify the file so as to resolve the conflict. So conflicts happen when branch merger can't be resolved automatically. Fixing conflicts is your job as the programmer. It's not merged until all the conflicts are solved, right? Also, it's tedious and nobody likes it, just so you know. The general workflow is, when a conflict occurs, Git puts something like this in the file with the conflict. So you'll see the branch name specified with, left version is this, right version is this, and it'll also specify the branch being merged, right? These will actually appear as actual characters that Git writes into your file, right? What you have to do is you have to go into the file, delete this, delete this, delete this, pick which one of these two is correct, right? Or, put the two on one line, or pick which parts of this are good and which parts of that are good, However that conflict needs to be solved, you are the person to do it, and it will probably, you can consider it a coding activity, because this will be some number of lines of code, this will be some number of lines of code, and you will have to pick the parts that are interesting and important in both, and manually create different lines of code which combine the two aspects that you want to merge together. It requires human intelligence to be able to do this, which is why Git leaves it to you. Make sense? The AIs are not yet so powerful. I don't think we have to worry about Skynet just yet if the AIs can't even manage Git merger. So, when a conflict occurs, the easiest way to fix it is to open up the file in your favorite text editor, which is obviously Emacs, and manually make the changes. That's a joke, by the way. Very few people actually like Emacs. This requires you reading the conflicting lines and figuring out what the solution should be. If the computer could have figured it out, it would have. Once you have resolved the conflict, or if you are or as you are resolving the conflict. Sometimes there's like a whole bunch of conflicts, so it's like useful to do commits as you're fixing conflicts, but you should say in your log messages, still fixing, like still some conflicts to fix, you know, so people don't try to compile it with these conflicts in it. They'll know that there are conflicts in the files. Etiquette. Etiquette. Once you've fixed the conflicts, push your changes so that everybody can see your changes so that they have the good versions of the files. Fixing conflicts is a major pain, and many team workflows have conflict avoidance as a top priority. People will go to a lot of trouble to avoid situations where purge conflicts might occur. That's being said, they are inevitable. And so you're going to just have to figure out how to deal with them. Rolling back to a previous version, even if it's just for a fact-finding mission, can be of critical importance. It can, you know, it might be very important to see what the code looked like back when it worked. You know? Good. So, boom. Commit your work. So I'll just, you guys want to see a demo of branching?
Yes.
We'll do it then. I had a repo here, didn't I? Yeah. Okay. So, Git online grab all what? Git log. There. So we currently have a very small repo that only has 2 commits in it, right? So let's pull a branch off of that. So git branch foo, right? Switch, git switch foo, switched to branch foo, git status on branch foo. Good. Now to make a modification to my file.c. This is also certainly not a C style conflict. It's LaTeX. And this one is Haskell. And this one is Python. Git add dot git net message added a few things. There we go. This is not a remote repository, so I don't have to push anything anywhere. Right? So we'll just skip that bit. Make sense? So if we take a look at the log, you'll see master is indicated here, foo is indicated there. Because this is still in a line, because master hasn't had any modification yet. Like, at this point, we could theoretically just merge foo right back into master, and we would there's absolutely no possibility of any merge conflicts because master hasn't had any commits since foo was created, right? So let's let's do it anyway. So switch master, git switch master, sorry. Switch to branch master. There we go. Git status. There we go. Get it. myfile.c. There we go. We can see this is still the old version of the file because I switched back to the older version that's stored in master. You know, I want to know, have you ever seen the rain? There we go. Put a space in there. Maybe put, you know, actually for SQL. There we go. Good. I've made some modifications. I have been careful to make modifications that are in conflict with the modifications in the other branch so that we have an actual conflict to actually address that we can see, you know. So git add dot git commit message. Who wants to know? There we go. Now, we are currently in master. We begin the merge operation. Git merge foo. Conflict. Merge conflict in myfile.c. Automatic merge failed. Fix conflicts and then commit the results. See, Git is actually really good because, like, if you just do what it's telling you to do, then everything works out. Like, if you do something incorrectly, it's usually pretty good at suggesting to you what you meant to do. So if you just listen to the damn software, it's usually pretty reliable. But all right, so let's see what my file, what Git has done to my poor file. So you'll notice it thinks that the whole bloody thing is in conflict, right? In technical point of fact, it's correct, because I did modify this line. That I guess I should have left one of these without modification, but you know, it is what it is at this point. So the thing that you have to do, go in here. Let's see, not a real C file, So we had this space, we want to keep the space, we want to keep that, there we go, so we can delete that. We can say, and Haskell, get rid of that. And this one and that one are different, so we'll just put the two of them together. Boom, boom, boom. There we go. Manual merge completed. Requires arbitrary decision making. Close that off. Git add dot. Git commit message fixed merge conflicts. There we go. Now let's take a look at the Git log. Git log, one line, graph, all. Boom. Make sense? Any questions? Yes?
Would if the code is the same in two different branches but the comments were different, would that also resolve the conflict?
Yes. Git is not interpreting things with respect to what is code and what is not. It is only looking at plain text in files. Therefore, you can actually use Git for a large number of things that aren't even code. You can use them for any plain text file, really. Like, for example, the LaTeX source code files that I use as my document generation system to produce the slides, not really code, but merge conflicts are still satisfied using the same mechanism in Git. Although I'm basically the only person who works on the slides, none of the TAs touch them, so. But yeah, like, this is like the system that I use to manage the course materials so that the TAs can like modify, you know, tutorial documents or assignment solutions and that sort of thing in a, you know, controlled manner so that everything's nice and easy, you know. Like, I actually use this for like a pretty big non-coding task, you know. It's useful just for file management, but any questions? Any other questions? All right, let's talk about C programming again then. So, we move swiftly onwards. Not so swiftly, maybe, but we're going to talk about functions. We're going to talk about we're going to talk about some memory concepts which are going to be useful later on in your careers, I'm sure. And we're going to talk a little bit about recursion at the end. How many of you have heard of recursion? It's a fairly major topic in computer science. Yeah, you'll see what we're talking about. So, functions are the basic units of abstraction in C. The way that they work is highly similar to Python, or I should say, Python is highly similar to C. Oh God, he's at it again. There are a few important differences. The return type of a function must be indicated where Python uses the def keyword, in theory. In practice as well, but in the abstract and abstruse sort of mystical apocrypha of the C programming language, it's technically possible to leave that off, and it defaults to integer. Yeah. In the absence of a declared return type, GCC will give a warning, and the return type will default to int. Curly braces are used instead of colon and indentation. Arguments must also have their types declared, and again, it defaults to integer. We are no longer in Python's loosey-goosey parametric polymorphism land. C will not decide, it will not keep the options open for what the type is and wait for you to use it to determine what type you meant when you declared the variable. That's what Python does. It will, in fact, require everything to be defined up front, and if you fail to define it, it will assume you meant integer. Because, to be fair, you probably did. While a return statement is not required, GCC will complain if one is not present. Unless it's a void function, I think. But anyway. If you don't want to return anything from a function, you have the option of declaring it void. And that means that you just use return with no expression instead of return with an expression. Make sense? So, for example, max function in Python, max function in C. Notice the declaration of everything as integers. Notice the use of curly braces. A more elegant weapon of a more civilized age. So let's take a look at the following poorly written function. While this will technically compile, the following warnings are found. Number one, return type defaults to integer, because no return type has been declared. Warning, type of X and Y both default to integer because return types have not been declared. Or input types, not return types. Anyway, warning, control reaches the end of a non-void function because we have commented out the part where we are returning anything. Right? This is not a useful function, but it will still compile. Right? So, this actually, like, if you were to write the equivalent in Python, this would not compile, because you are actually syntactically required to provide a line after an if statement. You can't just have an if statement with nothing in it. Even if you put a pass in there, you still have to put something in there. So this would not compile in Python. Questions? Good. So, this should be new. Function prototypes. So, in C, as in Python, in order for a function to be in scope, it must be defined before it's used, right? So, in a C file, you know, generally the way that C files are written is lowest level function to highest level function, with main at the bottom, because they must be defined before the next function that uses them is defined, in order for the references to be defined. That's like the general restriction in the absence of function prototypes. So, what a function prototype is you take the first line of the function, rather than opening it with a curly brace, you put a semicolon at the end of it, put that at the top of your file, right? That declares the interface of the function, allows that function to be used anywhere past the prototype. So it allows you to break out of the requirement to have things defined before they're used, because you are in fact defining it. It's kind of like declaring a variable without having instantiated it, right? You declare it up front, you instantiate it later. Same idea with function prototypes. Does that make sense? Generally speaking, when, like, at least probably in later assignments, I don't know if this is true on assignment 1, but in later assignments for sure, the typing information that will be provided to you for the functions I expect you to write will be provided as function prototypes. So, yes. So, in the previous example, if the function max is defined after main, GCC will produce the following warning. Implicit declaration of function max. Did you mean main? So, it'll suggest you the name of some function that is in scope that's, you know, like slightly off in the same way that a spell checker asks you if something's slightly off. Yes?
Our function prototypes is kind of used to make sure that the main function is more or less at the top, because that's mostly what we're focusing on.
Well, it allows you to put the main function at the top. Whether you do or you don't want to put the main function at the top is kind of up to you. It depends on how many functions you have, right? Like if you have 3 pages of function prototypes, like, you know, it doesn't really matter. Main won't be at the top, right? But yeah, it gives you the option, right? The other thing that it allows you to do is to have 2 functions which call each other, right? Because that type of circular reference, if one has to be defined before the other, that can't actually happen unless you have function prototype pre-declaring the types of both of them. Make sense? Good. So, early versions of C did not check for correct function usage at compile time, so the error would show up at runtime. Aren't we glad we don't live in those dark era, those dark days? Anyway, function prototypes solve the issue of having function typing information available while maintaining C's back compatibility with programs written before static function typing, or static function checking, was added to the standard. So, that is why this is a warning and not an error. And this is the reason a lot of things in C are warnings and not errors. Because there are old pieces of code still lurking in the kernels of various operating systems that do not use, if you were to make this an error, they would no longer compile. And you can't do that because you're C, right? You must maintain back compatibility or the entirety of Western civilization collapses. Because that's how important C is. Like seriously, the kernel of every server on the planet. So, to solve this problem, C has borrowed function prototypes from C++. This is like one of a very, very small number of features that has actually made it back to C from C++. So, this would be the function prototype for our max function. A function prototype is syntactically the first line of the function itself terminated by a semicolon. It is good practice to put function prototypes immediately after your processor commands, i.e., put them after the include statements. This declares the function up front, so its definition may now occur anywhere in the file without any warnings or any problems whatsoever. Many header files are composed only of function prototypes, and the function implementations are defined in libraries stored in system folders. Make sense? Any questions? Yes?
So the assignment, right? Like, you can break up assignment all the function resources that have the semicolon. So, like, if we were to replace that with a slash, would that result in a problem later on?
It's generally considered bad etiquette to take the function prototypes and like modify them and like replace the semicolon with a curly brace and right from there. Bad etiquette will still compile. You know, in future, just copy paste. Okay? Copy paste, then do it. Like I'm not saying don't copy the function prototype. Like obviously copy the function prototype, but like just do copy them, please. Just stylistically. Good. Any other questions? Yes.
It's actually about the assignment, and when we call our main function, if we're doing test cases, do we leave like numbers from past test cases instead, or what do we do?
That's an excellent question. I'm glad you asked it. So the question is, do I leave my old test cases in main? Like what's the deal? What's going on with that? I would like everybody to pay attention to me for just 4 seconds, because this is extremely important information for you to know. On the assignments, the autograder deletes your main function and adds one of our design. Right? So anything you put inside of the main function will not be marked. The only thing that will be marked is whatever is put inside of the functions we asked you to write themselves. We need to be able to insert our own code to perform our own test cases for the purposes of auto-grading. And the way we do that is by completely and arbitrarily destroying everything, main and everything it contains, and then providing one of our own and calling your functions. Make sense? So, taking input from standard input rather than taking it from the function arguments will get you a bad grade. Possibly 0, just straight up 0. Outputting your output using printf instead of returning the result from the function as you should will also probably result in 0, because we are like the standard interface by which input is given and output is taken is the function arguments and the return value. We are not concerned with you taking stuff from the users or printing stuff out for the terminal, unless the question explicitly says that. And I believe the last question on assignment 1 does explicitly call for that. That's the only one on that assignment. Make sense? Any questions about that? Have I been sufficiently clear? Have we stopped recording?
No, you want me to stop it?
No. I'm asking if we ran out of tape.
Oh, no, you're still good.
Okay, good. Do you have a question though?
Oh, yeah, I was gonna say, so if the function because when you download the code, the function has, let's say, int x, int y, all that type of stuff. Are we not allowed to read the input from the main loop and then put it into the function?
No, you totally are.
Okay.
That's how you should test it.
Okay,
It's
that's-
just
okay.
Any code that you put in main, we don't care about.
Okay, perfect. That's that's what.
You're welcome to test it however you like, you know, but we have our own way of testing it. So if you put the code that you want marked in main,
Be worried.
Yeah.
Got it. Okay.
got it?
Yep. Thank you.
Any other questions? Yes.
So like basically like when you decide what the variables are, you can all put that in for test cases. But for like the function itself, you just want like the computation and the return state, right?
Yes.
Okay.
Yeah. This makes sense? Okay. Take your easy, folks.
I'm gonna stop recording.